Okay, let's solve some of these limits that go to infinity analytically. So here's our first one, example 3a. I'm going to take the limit as x approaches 3 from the right of 2 minus 5x over x minus 3. Now tell me again, anytime I come to a limit, no matter what section I'm in, right? I just look at a limit, what do you have to do? Plug it in. Good for you. It's exactly what you're doing. So plug this in. I have 2 minus 5 times 3 over 3 minus 3. And look what just happened. I end up with negative, because it's a negative 15 plus 2 over 0. When you have a 0 in the denominator, and look at this. Oh, I've got this 0. I've got this issue associated with it. It's not 0 over 0, right? So that's a different situation like what we've already talked about, where you can simplify that down. I've got a number over 0. There's nothing I can do to factor this. There's nothing I can do to break this down, right? You have, and I'm looking at this, a negative on the top over that 0. That's how I know this is going to negative infinity. That's all there is to it. What are my numbers? If it's a positive over infinity, guess what's going to end up happening? So let's look at it right now. Let me go back to blue. I want to take the limit as x approaches 3 from the left of 2 minus 5x over x minus 3. Oh, here's the other thing that's going on with this one. As I'm approaching 3 from the right, look at what's happening. I should have said this, and I didn't. As I'm approaching this 3 from the right, because this is over 0 here, but it's also over the potential positive that I have. Because this is like 3.1, right? If we think about this here, wait, let me put it down here. So think about this like ghost style as 3.1. That's going to be bigger than 3, right? Right, so that's bigger than 3. So if I have a negative divided by a positive here, that's how I get my negative infinity. Look at what's happening with this next one. Let's go purple on it. I'm going to plug it in again. I've got 2 minus 5 times 3 over this 3, but 3 is coming in from the left, so it's like a 2.9, right? Even if I make this 2.9. I don't know, maybe that'll help sink this in a little bit. Because I'm approaching from the left, so just under 3 is what we're talking about. I know this number is still going to be bigger. Doggone it. This is still going to be bigger and make this a negative. 2 minus a bigger negative number. That's negative. On the bottom, I have 2.9 minus 3. Smaller than 3 is coming in, so that's also going to be negative. What happens when you have a negative divided by a negative? What do you get? And that's where the positive infinity comes from. All right. Okay. Moral of the story. If you have a one-sided limit, you're looking at this and saying, okay, I know I can't have something at 3 that puts that 0 in the denominator, and that also tells me I have that asymptote. But what is happening as I approach 3 from the right? As I'm approaching 3 from the right, that's a bigger number, like a 3.1 kind of number. So then that's going to keep that positive because 3.1 is bigger than 3. So a negative divided by a positive, because I know it's a 0 down here, so I know it has to go to infinity. Negative divided by positive is a negative. The same situation, a negative divided by a negative, because I'm coming from the left, so I know my value is smaller. You could potentially come up here and put, if it makes you feel better, that 0.1, 3.1 in there. I don't know. What makes sense, right? That's what I want to figure out with you. What makes sense that we're looking at? Because limits are not just plug and chug. You have to think it out a little bit, right? Think it out. when you're thinking this through, especially these infinite limits, what is the behavior of my graph? That's the question that you're actually asking. What is the behavior of my graph? And that's what you're figuring out. Let's do another one. Here's example 4. Oops, not on that page. Let's go ahead and come over here. We have the limit as x approaches negative 4 from the right of negative x cubed plus a 5x squared minus 6x over a negative x cubed minus a 4x squared. All right? Okay. When you have all these polynomials, factor that thing out. Factor that. Make that into something you can actually work with. If you see that, obviously there's greatest common factors there. So go with that. Use your algebra skills. Instead of trying to plug that negative 4 in, that looks crazy. I know that's our first rule. I know that's plugging it in, and we can look at this and get it plugged in and try to work with it. But frankly, I don't want to plug it in at this step, because I can factor this and then plug it in and make my life a whole lot easier. Right? If you have these crazy polynomials on the top and the bottom, make your life easy. That's what this is about. I can factor out a negative x from the numerator, and I get x squared minus 5x plus 6 over, I can factor out a negative x squared, and that leaves me with x here plus 4. Wow, that's so much nicer, isn't it? Negative divided by negative is a positive. One of these x's on top takes out one of those x's. And I'm going to factor that numerator too. Yes, I am. I'm going to factor that numerator also. Oops, pardon me, negative 4 from the right. And I'm going to get x minus 2, x minus 3 over x times x plus 4. Oh, right? It's that sigh of relief when you look at this and you're like, oh, that's so much prettier to plug into. It's also obvious that this negative 4 is hanging out with us. There's nothing I can do to cancel that out. There's nothing I can do to make that a whole. So I have to look at something going to infinity because it's going to put the 0 in the denominator. All of these are things that you're thinking as you work these problems. All right, well, if I'm taking negative 4 from the right, it's a negative 4, right? It's going to put me at a negative 3.9-ish, right? Okay, so when I'm looking at this, I'm going to plug this in, and if I think about this being a negative 4, I don't care what the actual numbers are. The only thing I care about, because I know this is going to infinity, as soon as I get a 0 in this denominator, I know that my answer is going to be either positive or negative infinity. I got to figure out which one it is. That's the moral of that story. If my number is on top, because I can't cancel anything, right? So it's going to give me a number on top, and I've got a 0 in the bottom, I know my answer is going to be positive or negative infinity, and I just got to figure it out. So if I look at this, if negative 4 minus 2 is going to be a negative number, right? Even the negative 3.9, that's still going to be a negative number. Negative minus 3, a negative number, subtracting off more, again with the negative number, over, whenever I plug in this negative 3.9 or whatever it is right here for this one, then I know that's going to be a negative number. But whenever I plug it in here, that number just below, and I'm adding 4, that's going to give me something positive. So a negative times a negative is a negative times a positive is a negative, and that is how I come up with a negative infinity. I'm going to pause, see if it soaks in. Right? I'm not concerned. what the number is. As soon as you see this is going to be a 0 in the denominator that I cannot cancel and make a whole, it's an asymptote. So my question now is, what am I going for here? What is it going to be, to the positive or is it going to be to the negative? And that's what I need to know. All right, so I know that I now have an asymptote, a vertical asymptote at x equals -4 because my graph is approaching negative infinity there. As I get closer to that, I go to negative infinity. All right. Okay, let's talk about asymptotes a little bit more here. Here's example 5. Location of vertical asymptotes. I have f of x is equal to, wait, let me write that. Find vertical asymptotes using limits. Oh, my handwriting is even worse. Sorry. Let me go down to the next line. Holy cow. Oh, dang. Let's try again. Using limits. Okay. I don't know, that all just went cuckoo on us for just a second there, didn't it? That's all right. We're back now. Of this function, f of x is equal to x squared minus 4x plus 3 over x squared minus 1. Now, you're still going back to your algebra, right? You're still going back and saying, okay, if this is a rational function, then I'm going to factor this. So I look and figure out, what am I even going to think is an asymptote, right? So what am I thinking could be an asymptote? And that's what we want to go for here. All right. This is x minus 3, x minus 1 over x plus 1, x minus 1. I have two issues with my denominator, right? X is equal to a -1 and x is a positive 1. Look at this right now and tell me what you know. Yes, good job. This is a whole, and this is going to be a vertical asymptote. But my directions tell me use limits to determine this, so that's exactly what we're going to do. So here, I'm going to take my limit as x approaches 1, right? By itself, 1, whenever I cancel this out and cancel this out, of x minus 3 over x plus 1. So my limit as I approach is 1 minus 3 over 1 plus 1. Oops, negative. All right, because that's a whole. So I have a value at that. And I'm going to reiterate this for the cheap seats. I used my limit notation here. As soon as I plug it in, you drop the limit notation, right? Because that you're performing that operation. You don't need to keep writing it. Let's go black. Now, I want to figure out the limit as x approaches -1 from the left of my function. I've got a 0 in that denominator. When I plug this -1 in, that puts me a 0 in the denominator, right? So as soon as I see this 0 in the denominator with the number on top, that's when I start looking at positives and negatives. That's a number sign. -1 minus 3, so a negative subtracting off more negatives is going to give me that negative. -1 from the left. right? So if I'm coming from the left of -1, that's going to be like a -1.1. It's going to be a bigger number because I'm talking negatives. And that's going to be a negative in the denominator. Good job. You see that? So if I plug this in, then that's going to keep me with the negative. So a negative divided by a negative is where I get that positive infinity. Look at what happens when I come from the other side. Oh, dang, I'm running out of room. That's okay. We got this. The limit as x approaches -1 from the right. Obviously, the same thing is happening, putting a 0 in the denominator. But when I take this -1, a negative and more negative, is going to be a negative in the numerator. But here, if I'm coming from the right, this is something like -0.9, right? Yes, that makes that positive because it's smaller than -1. So smaller, that -0.9 whenever you try to plug that in. And that's how we get our negative infinity. The moral of the story, when you try to figure these out analytically, you know there's a number over 0 that has to go to infinity. The big question is it positive or negative?